Today we are going to discuss paper solution of JEE Advanced 2017. As you know that JEE Advanced paper occur in two parts, paper 1 and paper 2. So first of all I am going to solve paper 1 for you, and then after we will solve paper 2. We are discussing code 0 of the JEE Advanced 2017. I am not writing down the details of each questions here. However, I will discuss what is the questions is all about. I will discuss what is question asking, what are the data given, but I am not writing down the question, each and every question here. So it is better to have a question paper with you with code 0. With code 0 of 2017, you can easily download it from internet, and if you have the code 0 of the paper, you will get benefited maximum from this solution. However, if you don't have the paper, you will easily understand what is the question asking all about and what is the answer and what is the solution. So I will first tell you that you should have the paper code. You should have the paper of 2017 JEE Advanced with code 0. If you have it, you will get benefited by maximum amount. So let us discuss the paper 1. We are discussing paper 1 of 2017. We are discussing paper 1 of 2017. So paper 1 solution we are going to do code 0. This is the solution that we are doing here. So the first question in chemistry paper was question number 19, and the question number 19 was the color of X2 molecule in group 17 elements changes gradually from yellow to violet in the group, down the group. This is due to, it is telling that as we move down, question number 19 we are solving, it is telling that in halogen, as we move down, color of the halogens X2 molecule gradually changes from yellow to violet. This is due to why? What is the reason behind this? The options are given as the physical state of X2 at room temperature changes from solid state, changes from gas to solid state down the group. First option is we have to explain the color change of X2 molecule, and the first option is it is due to the change of a state from gaseous state to solid state as we move down in the group. There is no direct relation of color change with a state of matter. You cannot say that if it is solid it will be violet, if it is gas it will be yellow. So this is incorrect. This is clearly incorrect. You can easily see that there is no relationship between color and state of the matter. So this is not correct option. Second part is decrease in HOMO-LUMO gap down the group. As we move down in the group, there is decrement in HOMO-LUMO energy gap, and that's why color change occurs. It is the correct option because color change is related to energy gap between the orbitals which occupy electrons and which doesn't occupy electrons. So it is the correct option. Color change depends on the energy gap between occupied orbital, electron occupied orbital, and electron unoccupied orbital. So what does it mean about HOMO and LUMO? If you look at the electronic configuration of X2, I am just writing electronic configuration of X2. You will see that we have sigma px2 pi to pi py2 pi pz2 and again pi star py2 pi star pz2 and then sigma px star 0. So this is the electronic configuration of X2. If you look at the HOMO, what is HOMO means? HOMO means highly occupied, or you can say that highest occupied, the energy orbital, highest occupied molecular orbital. Basically, it is telling that molecular orbital which has the highest energy. And you can easily see that highest occupied molecular orbital is pi star py. This is pi star here. You can see that is here the orbital, molecular orbital with highest energy and occupied by electrons are pi star here. And LUMO. LUMO is lowest unoccupied molecular orbitals. So lowest energy orbital that is unoccupied is basically here is sigma star. You can easily see that after this is the orbital, molecular orbital which is lowest unoccupied. So this is the sigma pl star, this is LUMO, and this is HOMO. This is highest occupied molecular orbital, this is lowest unoccupied molecular orbital in X2, in halogen. Now you know that color change occur due to excitation of electron from HOMO to LUMO. Color occur due to excitation of electrons from HOMO to LUMO. By light, by visual light. If energy gap is higher, lower lambda light, lower wavelength light will be absorbed. And if lower lambda light means higher energy light, because if energy gap is higher, high energy light photon will be absorbed. If energy gap is lower, higher lambda light will be absorbed. And the complementary color of the absorbed color is exhibited by molecule. Complementary color will be exhibited by the molecule. So if there is a low energy gap between HOMO to HOMO, you know that VIBGYOR. This is the increment in wavelength. Here 360 nanometer, here 760 nanometer. So if energy gap is lower, higher lambda will be absorbed. Higher lambda will be absorbed means red, orange, these are absorbed. And if these are absorbed, complementary color of these are white. So you can see that if we decrease the energy gap between HOMO and LUMO, higher lambda means yellow, orange, red, these light will be absorbed, and complementary color of green, yellow are violet, indigo. So violet color will be found. And if the energy gap is higher, lower lambda, these lambdas are absorbed, and so complementary color of these are these two. And so if the color absorbed is of blue or green, then color appear will be orange or red. Complementary color is nothing but, if you don't know complementary color, you should remember that complementary color is those color between two gaps. If violet is absorbed, green or yellow is appeared. If indigo is absorbed, yellow is appeared. If blue is absorbed, orange is appeared. If orange, red is appeared. So these are the complementary color of each other. You can see that if any molecule will absorb orange, red, it will be blue. If any molecule will absorb yellow, then it will be violet indigo color. So you should approximately remember that there is 2 gap among 7 color. There is 2 gap, approximately 2 gap of complementary color and color absorbed. So you are easily seeing that as we move down in the group, it is asked that color is changing from yellow to violet. It means that as we move down in the group, higher lambda are absorbed, and higher lambda will be absorbed when energy gap is lower, because higher lambda means lower energy of photon. So this is the correct option B, which is telling that decrease in HOMO-LUMO gap down the group. This is the correct option. B option is correct option. Decrease in HOMO-LUMO gap down the group. And third part is again same terms is written in decrease in pi star sigma star gap down the group. So both are actually same options. B and C are actually same options are telling in different languages. Actually pi star means HOMO here, sigma star means LUMO here. And last option D is given as decrease in ionization energy down the group. It is telling that color change is occurring from yellow to violet due to decreasing ionization energy down the group, which is again wrong. Color change is due to energy gap difference between HOMO and LUMO orbital, and so the correct option for this one, question number 19, will be B and C. This is a multiple choice answer correct. Actually in section 1 there are 7 questions of more than one answer correct type. So we are solving this type of questions, more than one answer correct type. You can easily understand the concept of this question here. The next question is question number 20. And question number 20 is again from inorganic chemistry, and it is of coordination and salt analysis. It is telling that addition of excess aqueous ammonia to a pink colored aqueous solution of MCl2 6H2O. It is told that MCl2 6H2O, that is X, and is pink color. And it is pink color. And it is told that we have to add excess ammonia here. Excess ammonia here. And NH4Cl. And NH4Cl. We have to add excess ammonia in presence of air. In presence of air. We have another complex Y. This is again another complex Y. And it is 1:3 complex. Means it is giving 1 cation and 3 anions here. Electrolyte. The reaction of X react with HCl at room temperature gives blue colored complex Z, and spin magnetic moment of X and Z mu is 3.87 Bohr magneton for X and Z, whereas 0 for complex Y. Among the following options, which statement are correct? Among the given options, which options are correct? This is the question here. Now, if you look at the complex given here, you can easily see that we have question number 20 as MCl2 6H2O, that is X, excess NH3, NH4Cl in presence of air, it is forming Y complex, that is 1:3 electrolyte. 1:3 electrolyte, not 1:3 complex, 1:3 electrolyte here. And again, if HCl is passed on XZ complex is forming, and the options are given are the hybridization of central atom in Y is G2sp3. B option is when X and Z are equilibrium at 0 degrees Celsius, the color of the solution is pink. Z is tetrahedral complex, and addition of silver nitrate to Y gives only 2 equivalent of silver chloride. These are the options here. First of all, the color of the complex you have to think about. There is only one cation whose color is pink, that is cobalt 2 plus. Cobalt 2 plus has pink color. And it means that this implies that X is nothing but H2O whole 6 and Cl2. COH2O whole 6 Cl2. You know that CO2 plus has coordination number of +6. Now, if you react COH2O whole 6 Cl2 with excess NH3, you are knowing that NH3 is a stronger ligand than H2O, and that's why H2O will be replaced by NH3. So I am telling that if NH3 is a strong ligand, if we react this one by NH3 excess in presence of NH4Cl, we will have CONH3 whole 6 Cl2, and again in presence of air it is getting oxidized. Cobalt will get oxidized in +3, and this is the Y. This is the complex X and this is the complex Y. Now other part is when we pass HCl on X, we have, when we pass HCl on X, here another complex, that is blue colored complex ClO4 2- is going to form. Basically is a tetrahedral complex, and it is octahedral complex, and that's why it is less stable, it is more stable, and hence it is endothermic process. Delta is positive, and it is a reversible state. This is the most difficult portion of this question. In this question, a student can easily predict the first part, that is when we react X with NH3 excess and NH4Cl, CONH3 whole 6 Cl2 is going to form, and then after oxidation with air it is going to occur in +3 oxidation state. But if we pass HCl, 6 coordination number will convert into 4 coordination number. This is the difficult part of this question. I will consider this question as difficult one because of this revision, because of this problem. This is going to be X and this is going to be Z. This tetrahedral complex is going to be Z. So we have all 3 complexes here, X, Y and Z. First of all, we are going to write, we have written X, Y and Z here, and now we are looking at the properties of X, Y and Z and looking at the options given here. So X is COH2O whole 6 Cl2. You can see that cobalt is in +2 oxidation state, so we will have argon, and now we have argon and 3D. You can see that 3D7. So we will have argon because H2O is just weak ligand. So we have arrangement of electron as this one, 3 unpaired electron. This implies that magnetic moment will be 3.73 Bohr magneton by using formula under root 3 into 3 plus 2 Bohr magneton. You know that the magnetic moment formula is under root n into n plus 2 Bohr magneton. So we have mu for x1, x will be this one. Now if you look at the Y complex, we have Y as CONH3 whole 6 Cl2, and you know that Cl3 not, it is getting oxidized. Why this one? So cobalt is in +3. So we have argon 3d6. Also NS3 is a strong ligand. NS3 is a strong ligand with cobalt 3 plus. And if NS3 is a strong ligand with cobalt 3 plus, we have argon, and the electronic arrangement will be this one. And you can see that the hybridization of this complex will be going to occur as D2sp3. This is the first part of the question. It is telling that Y has hybridization of D2sp3. That is correct. A option is correct. A option is correct because it is telling that Y has hybridization of D2sp3, which is correct. You must be knowing that NS reactor is a strong ligand with cobalt 3 plus and copper 2 plus in first row of 3D. First row of D block, because first row of D block, that is 3D series. So Y has this one, D2sp3 hybridization. X and Z in equilibrium at 0 degrees Celsius. The color of solution is pink. We have to compare X and Z now. So if we look at the equilibrium of COH2O whole 6 Cl2 and equilibrium of COCl4 2 minus, you must be knowing that it is more stable, and hence at 0 degrees Celsius this one will be dominant. This is blue color, this is pink color. So at 0 degrees Celsius X will be dominant. X will be dominant because it is more stable compared to tetrahedral complex. It is less stable tetrahedral complex, and so the color of solution is blue at 0 degrees Celsius. So at equilibrium, you can see that color of solution is pink because the equilibrium shifts backward. Because of more stability of X, at equilibrium more of X will be dominant, and so color of solution will be color of X, that is pink, not blue. Blue is the color of Z. Now you are also seeing that Z is a tetrahedral complex. It is the C option, so it is the B option here. So B is also correct. Now you can see that next option C is given as Z has tetrahedral complex. Z is tetrahedral complex, which is again correct. Tetrahedral complex is this one, which is again correct. And now the addition of silver nitrate to Y gives only 2 equivalent of silver chloride. Next part is telling that if we add silver nitrate to Y, we have 2 equivalent of AgCl, which is wrong. We have 3 equivalent of AgCl, not 2 equivalent of AgCl. 2 equivalent of AgCl is not going to form here. 3 equivalent of AgCl will form because you can easily see that there is 3 chloride ion outside the complex sphere, and so 3 equivalent of AgCl will form. So the correct answer for this one was A, B and C. 3 answers are correct here. You can justify these answers by above explanation that we have done here. It is a difficult question of salt analysis and complex compound. It is combined questions of salt analysis and complex compound. The next question that we are going to discuss is of physical chemistry chapter, thermodynamics. Very typical question. This type of question are frequently asked by JEE. It is based on first law of thermodynamics, and question is telling that an ideal gas is expanded to P1 V1 T1 to P2 V2 T2. We have an ideal gas that is expanded from P1 V1 T1 to P2 V2 T2. We have P1 V1 T1 to P2 V2 T2. I am just arbitrarily writing 2 points, and expansion is done from P1 V1 T1 to P2 V2 T2, and we have to justify which options are correct. So the A option that is given is if the expansion is carried out freely, it is simultaneously both isothermal as well as adiabatic. The question is saying that if expansion is done freely, means expansion is free. It is told that expansion is free. Expansion is free means W irreversible. It is a reversible process because P external is equal to 0. Internal pressure must be there because gas is present there. So we have P external dV. This is the integration and that is going to be equal to 0. So from first law of thermodynamics, you must be knowing that Q plus W is equal to delta U, and since we have W is equal to 0, Q is equal to delta U. Now the option is telling that if expansion is carried out freely, that we have done W is equal to 0, it is simultaneously isothermal as well as adiabatic. So if isothermal process, delta U will be 0. Delta U will be 0. This implies that Q will be equal to 0 because delta U and Q are equal. If adiabatic process, Q will be equal to 0, this implies that delta U will be equal to 0. Means you can say that if it is isothermal, it will be adiabatic, and if it is adiabatic, it will be isothermal. So the process is simultaneously adiabatic and isothermal. So this option is correct. A option is this one is correct. Process will be both isothermal as well as adiabatic. Next part is the work done by the gas is less than when it is expanded reversibly from V1 to V2 under adiabatic condition as compared to that expanded reversibly from isothermal condition. The question is telling, next part is B. B is telling that we are doing expansion isothermal or adiabatic. We are doing expansion isothermal, or you know that adiabatic process has more flow at constant volume. If we do expansion P1 V1 T1, this is isothermal and this is adiabatic. You can easily know that W isothermal will be greater than W adiabatic. We have done reversible process. We can easily see that area under the curve. You know that W is equal to area under the curve. Work done modulus, W modulus means work done by system will be simply equal to area under the curve, or you can easily see that W isothermal is above than W adiabatic. The graph of isothermal curve is above than graph of adiabatic curve, and that's why W isothermal will be greater than W adiabatic. So the B answer is also, B option is also correct for this one. The next part is telling that the work done by the gas is maximum when it is compressed irreversibly. C part is when it is compressed irreversibly from P2 V2 to P1 V1. It is telling that we have P2 V2 and we have P1 V1, and if we do expansion irreversibly, sorry, not expansion, it is compression. If we do compression irreversibly at pressure P1, so at pressure P1 compression will be done as follows. At pressure P1 compression will be done as follows. So you can see that this is the maximum pressure at which compression can be done. So W irreversible will be equal to minus P1 and V1 minus V2, and you can easily see that P1 is the maximum pressure. P1 is the maximum pressure, and so work done on gas is maximum. Work done on gas is maximum. P1 is the maximum pressure, and that's why work done on the gas is maximum. You can easily see that area under the curve. In this process there is no work done, and in this process the work done will be maximum because area under the curve will be maximum. From P2 V2 to P1 V1, this is the maximum area under the curve that can be obtained. So C is also correct. So C option is also correct here. Now we have to compare D option. D option is telling that, D option is here, the change in internal energy of gas 1 is 0 if it is expanded reversibly with T1 is equal to T2. So delta U NCV delta T is always NCV T1 minus T2 minus T1. If T1 over T2, that is equal to, if T1 over T2, that is equal to final and initial temperature are equal. So delta U first will be 0 and delta U2 will be again NCV delta T, that is NCV T2 minus T1. Now it is telling that the process is adiabatic condition. Adiabatic condition and its expansion. Adiabatic expansion is happening. If adiabatic expansion is happening, you must be knowing that volume is increasing. This implies the temperature is decreasing. That is because by using T to the power gamma minus 1 is equal to constant. You know that there is a relationship between temperature and volume, that is T to the power gamma minus 1 is equal to constant. And if temperature is if volume is increasing, temperature must decrease here because gamma minus 1 is positive. So temperature is decreasing, and that's why you can see that T2 is less than T1. So T2 is less than T1, this means it is negative, and according to the option given here, it is given as positive. So D is wrong. D is wrong because for first gas it is given correct because T2 is equal to T1. It means the internal energy change will be equal to 0. But for second portion, it is given that for adiabatic expansion we have delta U will be equal to positive. It is not correct. Delta U will be negative because temperature is decreasing here. So for this question, the correct answer was A, B and C. These are the three options which are correct in this part. So this is the question number 21 that we can easily see. The next question is again from physical chemistry and it is from 12th portion, solution and colligative property. Question number 22 and it is from solution and colligative property. And the question is saying that for a solution forming by mixing liquid L and M, the vapor pressure of L plotted against the mole fraction of M as shown in the figure. We have been given vapor pressure of L against mole fraction of M. Mole fraction of M, it is here 1, it is here 0, it is vapor pressure of L. And this is like, this is the curve here. XL and XM represent mole fraction of L and M respectively in the solution. Correct options applicable to the system is are. Options given for this one is. As you can see that it is vapor pressure of if it is XM, there is 1 here, so XM will be 0 here and XL will be 1 here. You must know that for ideal gas we have vapor pressure like this one. Ideal PL is equal to P naught L into XL. This is ideal solution. And from the graph it is clear that PL observed. From the graph it is clear that PL observed is greater than P ideal. It means that the solution has positive deviation from Rod's law. It is the condition of positive deviation. If vapor pressure observed is greater than ideal vapor pressure obtained by Rod's law, that is positive deviation. If vapor pressure of solution observed is less than ideal vapor pressure, then it is negative deviation. So it is positive deviation. And if it is positive deviation, interaction between L and M, positive deviation means higher tendency to get vaporized. So interaction between L and M is weaker than LL and MM interaction. And the option 1 is given as attractive intermolecular interaction between LL in pure liquid L and MM in pure liquid M are stronger than that between LM when mixed in the solution, which is correct. So A option is given simply this one. It is telling that LL interaction and MM interaction in pure liquids are stronger than LM interaction in solution. It is correct. I have written here. Positive deviation means interaction between L and M is weaker. That's why gas is forming in larger amount. Vaporization is happening in larger amount. So A option is correct. B option is telling that the point Z represent vapor pressure of pure liquid M. Point Z represent vapor pressure of pure liquid M. That is incorrect. It is not vapor pressure of pure liquid M. It is vapor pressure of pure liquid L. It is vapor pressure of pure liquid L. Again C option. So this is incorrect. Again C option is given as point Z represent vapor pressure of pure liquid M. Again it is incorrect. D part, you can see that it is telling that the point Z represent vapor pressure of pure liquid L when Rock's law is obeyed when XL is equal to 1. At Z, you can see that XL is equal to 1, XM is equal to 0. It means that XL is equal to 1. So it's a pure liquid L. So Rock's law is followed. Rock's law is easily followed here. Is followed, and Z represent vapor pressure of pure liquid L. And Z represent vapor pressure of pure liquid L. So this is the question number 22 here. The next question is question number 23. It is from organic chemistry, which is a very easy question based on nomenclature. And this question is this one. We have to write the nomenclature of this compound here. Some people are telling that this question is ambiguous because there are many different nomenclature possible for a single compound. But the IUPAC system, IUPAC nomenclature, which is available for this one is, first of all, toluene is accepted by IUPAC system as a standard nomenclature. So you can see that 4-chlorotoluene. This is the answer, first answer here. So this is the B option. So B option is correct. Now again we can see that we can write a chloro and methyl. So if we write in alphabetical order, 1-chloro, 4-methyl benzene. So this is also correct, and this is the option A here. So A and B are correct here. Here in 22, A and B are correct. So you can see that for nomenclature of this compound, that is in benzene at 1 and 4 position, methyl and chloro is attached. Two nomenclatures are possible. One is with benzene, CH3 is named as toluene. So it can be named as 4-chlorotoluene. And now if we write the naming of substituent in alphabetical order, this is 1-chloro, 4-methyl benzene. So these are the two options that are correct here in 23 number questions. The next question is based on addition reaction. Question number 24. It is from organic chemistry, and it is telling that if we add, this is transform, if we add Br2 in CaCl3, we are going to form M and N. You must be knowing that it is trans, and Br2 will add according to anti-addition, and trans and anti-addition will give meso. So M and N are same compound. Basically M and N are identical. You can see that M and N are identical, and they are nothing but this one H, Br, H, Br and CH3. So this is the compound that is going to form here. You must be knowing that on symmetric addition or elimination reaction, you must be remembering that cis, syn, meso. This is the rule here. Cis, on cis, if syn addition is occurring, meso will be formed. By using this rule, if we replace cis by trans, syn by anti, so on trans compound, if anti addition is occurring, again meso will be formed. So on trans, if anti-addition is happening, meso will be formed. Now the second compound is CH3, CH double bond CH3 and H. This is the cis form, and if again Br2CH3 is adding here, so anti-addition is going to occur. And if we telling O and P are formed, so these are DL pair. So these are DL pair. It means that the compounds will be as follows: CH3 H Br Br H CH3 and CH3 H Br H H Br and CH3. So these are the two compounds O and P, and that M and N are same compound. So we have the options given here are O and P are identical molecules. Wrong. This is DL pair. O and P are identical molecules. A option is telling that is wrong. B option is bromination proceed through trans addition in both the reaction. Trans addition means anti-addition. Anti-addition is happening in both cases. So this is correct. Anti-addition is happening in both cases. Trans addition is happening. Trans or anti means from opposite side Br minus and Br plus will be attached. If syn addition is happening, it means Br plus and Br minus are attached from same side. C option is M and O, and N and P are pair of enantiomer. That is wrong. Pair of enantiomer are O and P. M and O and M and P are basically diastereomer. So this is wrong. D option is M and O, and N and P are two pair of diastereomer. That is correct. M and N are identical compounds, and M and O are diastereomer because you can see that stereochemistry means RS configuration is maintained at one asymmetric center, and RS configuration differ at other configuration. So the correct option are B and D for this particular question. This is the question number 24 from organic chemistry, and the correct answer was B and D. B and D are correct for this option. The next question is question number 25. And question number 25 is from inorganic chemistry. And the question is the correct statement about the oxyacids HClO4. We have to tell the correct options for HClO4 and HClO. First of all, it is telling that conjugate base of HClO4 is weaker base than H2O. If you look at the acidic strength here of HClO4 and water, you can see that HClO4 is much stronger acid than water. So basic strength of conjugate base, ClO4 minus and OH minus. OH minus has a higher basic strength compared to ClO4 minus. So this is the correct answer here. Basic strength of ClO4 minus will be less than that of OH minus. It means that A option is correct. A option is correct. A is correct here because it is telling that conjugate base of HClO4, that is ClO4 minus, will be weaker base than conjugate base of H2O. Conjugate base of H2O. Even from H2O, if you look at the H2O, basic strength of H2O, from H2O also, the basic strength of ClO4 minus will be less. It is not telling that conjugate base of HClO4 is weaker base than conjugate base of H2O, but it is telling that basic strength will be less than from H2O. That is correct because H2O is an amphoteric substance, and if you look at the Kb value, I will check it. The question is asking about basic strength of ClO4 minus. If you look at the HClO4 Ka value, that will be equal to approximately 10 power 9. So Kb of conjugate base will be equal to approximately, I am telling that. So this will be equal to Kw upon K, that will be equal to 10 power minus 21. I think 21, 14 and 23. And if we look at the H2O, Kw value is equal to 10 power minus 14. So if you look at the Kv value of H2O, so Kv value of H2O, that is equal to Ka or Kv value or Kw is equal, because it is telling that H plus or OH minus from this one is going to be equal to H plus OH to 10 power minus 7m. And if we look at the Kw value of H2O and Kv value of ClO4 minus, you can easily see that water is stronger base than ClO4 minus. You can easily see that ClO4 minus has weaker basic strength than even H2O. And this is the question that is asking here. So ClO4 minus has weaker basic strength than H2O. B part. The hybridization of HClO4, central atom of HClO4 and HClO is sp3. This is again correct. You can easily calculate hybridization here. N is equal to here half V plus M minus E plus A, that is equal to 4, that is equal to sp3 hybridization. Again from this one and S, from second one, half 7 plus 1 again, this is 4, that is again sp3 hybridization. So this is again correct. A option is correct, B option is correct. Now the question C part is telling that HClO4 is formed by H2O and Cl2 combination. That is not correct. If you combine H2O and Cl2, we will going to form HOCl plus HCl. That is the compound that is going to form here. Means the second acid will be formed here, not HClO4. So this is D. C option is wrong. D option is HClO4 is more acidic than HClO. Acidic strength is higher. That is correct. Acidic strength of HClO4 will be higher because ClO4 minus is more stable than ClO minus. Because you can see that here minus charge is more resonance stabilized with double bond here. You can see that minus charge is more resonance stabilized, whereas in ClO minus there is no resonance stabilization of minus charge. And since conjugate base is more stable, it means that the acidic strength will be higher. So again D option is correct. So here the correct answer are A, B and D. So this is the section 1 of paper 1 of code 0 of JEE Advanced 2017. In this part we have solved 7 questions of more than 1 answer correct type. In next class we will solve some more problems on section 2.